Friends, in this meeting we will study the refraction through the prism. So consider the prism ABC as shown in the figure. Let's say a ray strikes the face AB as shown in the figure. This is the angle of incidence. Okay, let's say I is the angle of incidence. And E is the angle of emergence. Okay. Now friends, by how much angle this incident ray is deviated? Okay. Initially the incident ray was moving in this direction, and finally the emergent ray is moving in this direction. Okay. So the angle between the initial direction of the ray and the final direction of the ray, that is the angle between the direction in which the incident ray was moving and the final ray was moving, is called as angle of deviation, rho. Okay, so you can see that by an angle rho, the ray has been turned, okay, clockwise. So we say that the angle of deviation is rho. Okay, how we define angle of deviation? Angle of deviation is nothing but angle by which the incident ray is turned. Okay, so that is nothing but the angle between the direction of incident ray and the direction of emergent ray. Okay, so friends, A is the angle of prism, which is defined as the angle between the two faces of the prism. One of them consists of the incident ray and the another contains the emergent ray. Okay, so angle of prism is angle A. Okay, how we define angle of prism? It is the angle between the two faces which contains the incident and the emergent rays. Okay, now let's do one thing. Let's apply the Snell's law. Okay, and obtain an expression for the deviation. Friends, let's say this angle of refraction is R1 and this angle is R2. Further, let's give these points a name. Let's say D and E. Now friends, if we consider triangle ADE, this triangle, then the sum of these interior angles of the triangle will be 180 degree. Okay. Now one of the angle is this angle A. Okay. Now friends, we also know this angle is 90 degree because this is normal to the face AB, and this angle, that is the angle EDF, is R1. So the angle left, that is this angle, is 90 minus R1. Okay. So angle ADE is pi by 2 minus R1, and in the same fashion angle AED is pi by 2 minus R2. Okay. So let's take all three angles of this triangle and sum them. We will get pi. Okay. So A plus pi by 2 minus R1 plus pi by 2 minus R2 equal to pi, and therefore we can say that A equal to R1 plus R2. Let's say this is our equation number 1. Okay. Now further friends, if I call this point as O, and if you take the triangle ODE, triangle ODE, okay, then this angle rho is the exterior angle of the triangle. Okay, and therefore rho is equal to sum of these two angles, that is ODE, angle ODE plus angle OED. Now friends, angle ODE is I minus R1, and angle OED is E minus R2, and therefore angle of deviation rho is I plus E minus R1 plus R2. But we have just proved this R1 plus R2 is nothing but A, and therefore I plus E equal to A plus rho. So friends, we have related angle of incidence, angle of emergence, angle of prism, and the deviation angle. Okay. Now suppose, once again, this is the prism. Okay. And this is the angle of incidence and emergence. Friends, what do you think? What will happen if suppose this part of the prism is broken? Suppose this part does not exist. In that case, do you think this ray will be affected? Well, answer is no. Answer is no. What do you think? What will happen if this part of the prism is not there. Okay, let's say this part is broken out. That is, we have only this much part of the prism. In that case, friends, in that case, do you think this ray will be affected? Well, answer is no. Okay. So, it's not as if the prism should be of this shape only. Okay. Suppose you have been given that this is the piece of a glass. This can also be treated as a prism. Okay. For this ray, we can treat this piece of glass as prism. And the angle of prism will be the angle between the two faces which contains the incident ray and emergent ray. So this will be the angle of prism. Okay. And then obviously this will be the angle of incidence, this will be the angle of emergence, and this will be the angle of deviation. Okay. And of course the result I plus E equal to A plus rho will hold, and A equal to R1 plus R2. This result will also do. Okay. Now friends, you can observe that angle of deviation depends on angle of incidence. Correct? So if I plot angle of deviation versus angle of incidence, then the graph will be something like this. Okay? Why? Because in this equation I plus E equal to A plus rho, if you replace I by E and E by I, in that case also the equation remains unchanged. Okay? That is, the equation is symmetrical for I and E. And therefore, you see, for a given angle of deviation, two values of angle of incidence is possible. Okay? How come? Let's understand it once again. We have just derived I plus E equal to A plus rho. Okay? For a given prism, A is fixed. Let say for some prism A is pi by 3. Okay? We have an equilateral prism. In that case, therefore the equation becomes pi by 3 plus rho equal to I plus E. Okay? Now friends, using the principle of reversibility of light, we can say that if the light will incident on the face AC, okay, then it would have retraced. You see, if you keep a mirror perpendicular here, then the light will be reflected back and it will retrace the same path due to the principle of reversibility of light. Okay? In that case, I become E and E become I. Okay? But the angle of deviation remains the same. Okay? When the ray was incident on the face AB, this case, then angle of deviation was this angle, and when the ray is reflected back, then angle of deviation will be this angle, okay, and both these angles are equal as they are a vertically opposite angle, okay. What is the moral? Moral is, if I become E and E become I, okay, in that case angle of deviation will be same, okay. That was anyway expected also. Why so? That's quite clear from the equation. Equation is symmetrical in terms of I and E. So if I and E are interchanged, okay, then the rho will not be affected. That means for a given angle of deviation, there are two angles of incidence. One is I and another is E. Okay. So if you plot I versus E, if you plot rho versus I, okay, then the graph will be something like this. So we can see that for a given angle of deviation, there are two angles of incidence, okay. One corresponds to I, another corresponds to E, okay. At some stage, the deviation will be minimum, and at that location, these two angles I and E, they will be same. So if I and E are equal, then deviation will be minimum, okay. That is, deviation will be minimum if I equals to E. Okay. And friends, as we know, I plus E equal to A plus rho. Now since deviation is, let's say, minimum, therefore I and E are equal. Therefore we can say that angle of incidence in that case will be A plus rho min by 2. Since I and E are equal, therefore R1 and R2 must also be equal from Snell's law. Okay. Since R1 and R2 are equal and R1 plus R2 is A, therefore we can say that R1 equal to R2 equal to A by 2. And if you use the Snell's law, then mu equal to sin I by sin R1. I is nothing but A plus rho min by 2 and R1 is A by 2. So mu equal to sin of A plus rho min by 2 upon sin of A by 2. Friends, we'll discuss from here onwards in the next meeting.